Let's try some practice questions with moles and particles. If I say I have 2 moles of sodium chloride, how many formula units of sodium chloride do I have? Okay. This is where our conversion factors use will come in very handy. You always begin by what's given. You're given 2 moles of NaCl. You're asked for how many formula units of NaCl do you have. I'll write what's given right there, 2 moles. Moles is represented as a unit by just writing MOL. So this is a short form, just like kilometers is used as km. Moles is used as MOL. Now 2 moles of NaCl. Always write what you have the moles of. Just like if I was to say I have 2 dozen, what? If I just say 2 dozen, it doesn't give me any more information that I have 24 of something. But if I write 2 dozen apples, then I know what I'm talking about. So similarly, this is your apples. You always write what you have there. Your final answer, you need to find formula units of NaCl. Okay, this is where you need to understand your idea of particles, that formula units is just referring to particles of NaCl, nothing else. So because I'm given moles and I'm going through particles of something, moles is what needs to be cancelled out. I don't want moles of NaCl. Instead, what I want is formula units of NaCl. And that formula units is particles. So the conversion factor you're using there is 1 mole is equal to 6.02 times 10 to the power 23 of anything. In this case, 1 mole of NaCl will be equal to 6.02 times 10 to the power 23 formula units of NaCl. 1 mole is equal to 6.02 times 10 to the power 23. Keep this in mind, not the other way around. You have these numbers where you put them is very important. Now you can cancel out moles with moles. You're left with your answer. I'm sure that before we even started answering this, some of you may even have realized, well, I don't really just need to multiply by 2. To show your work, it's important that we do this. And right now it's a straightforward question, so it's easy. Practice conversion factors, because down the road, as you'll see, you'll be forced to use conversion factors. Otherwise, you won't be able to get that simple answer. Okay? Because you'll have different numbers and you'll have multiple steps involved. In this case, it's a simple answer, 2 times 6.02 times 10 to the power 23, which is 1.2 times 10 to the power 24. That's your answer. A similar problem can be given to you in reverse. So you could be given, let's say, 5.34 times 10 to the power 26. Any number. 5.34 times 10 to the power 26 molecules of methane. Okay, and how many moles is that of methane? Same approach, you always begin by writing down what you're given. 5.34 times 10 to the power 26 molecules. Now do not use MOL as a short version for molecules or MOLE. You must write the word because otherwise it can be easily confused with the word moles. So 5.34 times 10 to the power 26 molecules of CH4 is what's given. What I want instead is moles of CH4. So the conversion there I'm doing is from molecules to moles. There is a direct conversion, which is 1 mole of anything is equal to 6.02 times 10 to the power 23 particles, right? Molecules is a representation of particles. Just like I don't have to tell you what apples are, you know that that's quantity of something. So molecules is quantity of something. 6.02 times 10 to the power 23 molecules. That is the conversion factor I'm using. Molecules need to be canceled out, so they go at the bottom. Moles go at the top. 1 mole is equal to 6.02 times 10 to the power 23 molecules. This is how you know where the number is going. In this case, as you saw, the 6.02 times 10 to the power 23 went at the top. It goes at the bottom because it's this many molecules. Always refer back to your conversion factor and make sure that the number goes with the word. Number goes with the word. Okay? Right, all that is left is to cancel out molecules and do the math. You divide these two numbers. Now, when doing math like this, keep in mind how you're dealing with the denominator. Okay, a lot of the times students will get answers that are unreasonable. When you put this in your calculator, make sure that for the denominator you put everything in brackets like this. Right now there are 2 things being multiplied here, but even if there were other numbers, just make sure everything is put in brackets. And here's why. If you insert this in your calculator, let's say as you see it, or as you write it, 5.34 times 10 to the power 26 divided by 6.02 times 10 to the power 23. As it appears there, you can see that the power is to the 48. You know that's not true. When you divide something that is 10 to the power 26 and 10 to the power 23, there's a difference of 3 zeros there. So why are you getting that large number? The reason is you're not putting the denominator in brackets. It's multiplying. What it's doing is it's multiplying these two, dividing it by 6.02, and then multiplying that whole number by 10 to the power 23, which is not right. So to tackle that, you always want to make sure that you put the denominator, everything in the denominator, in brackets. So here's how I would type that in. 5.34 times 10 to the power 26 divided by brackets. Put everything in brackets. 6.02 times 10 to the power 23. Close the brackets, and now you get an answer that's more manageable, that makes more sense. Always check your answers. So you see it's 887.04, which is within the reasonable number of zeros. It's close to 1,000. If you were to round this to the nearest thousands, it would be 1,000, and that's what this divided by this should give you, 1 with 3 zeros. Okay, so you can keep that number as is, or you can write it as 8.87 times 10 to the power 2 moles of CH4.